Hello, I'll be demonstrating the use of the SOTA magnetic pulsar. The latest model is shown here, our model MP6. Before we get started, I just want to draw your attention to our operating manual. Please do remember to read the manual from cover to cover. It's a great manual, has lots of good information, specifications, troubleshooting, and everything you need to know about operating your magnetic pulsar. The magnetic pulsar is powered by an AC to DC wall adapter. The specifications are 12 volt DC, 1.5 amp output, and very important that the polarity is center or tip positive. If you have a wall adapter that you're not, other than ours, if you're using your own, please remember to have the same specifications. If the polarity is reversed, it won't hurt the unit, but the unit simply won't turn on. If you don't have the correct voltage or amperage settings, the unit may turn on, but it'll take a long time to charge up. So please either use our wall adapter or make sure the one that you have the correct specifications. What makes our wall adapter unique are the blades. For every different country, there are different blades that you use to plug the unit into the wall. And so this for North America, we have certain blades. For your country, it may be different. And you can order blades for your country. It's really nice. You can snap these blades out and replace with your blades and pop it back into place and you're good to go. I've already got the wall adapter plugged in here, and I'll show you the operation of the unit. On the back of the unit, there's a power outlet, and of course you just take the plug it into the power outlet. On the front of the unit there are two buttons, a large on-off mode button and a little button up here which is actually for an audible feature, and I'll demonstrate that in a moment. The magnetic pulsar, the MP6, is a 2-speed pulsar. When you first turn on the unit, the unit will charge up in regular mode. If you hit the mode button once, the lights return from green from regular mode to yellow in high speed mode. And then if you want to turn the unit off, you hold the button down and for about 2 seconds and the unit will turn off. At any time when the unit is operating, you want to hear a beep to indicate the release of the magnetic field, you would hit the audible button. A yellow light will come on indicating it's an audible mode. So let's demonstrate that now. Turn it on, the unit starts up, and you should see a series of green lights building up. And at the very moment I just heard it pulse, at the very moment that the pulse is built up to the highest level, a red light will flash. At that moment that the red light flashes, the magnetic field has been released. I'll turn on the audible option. You'll see a yellow light come on and there's a beep. So now for those who are visually impaired, you can get an indication each time the magnetic field is released. I'm going to now go into high speed mode. This is regular mode. As you can see, you have a series of green lights. I hit the mode button once and now we're in high speed mode. As you can see, it's pulsing much faster, almost about once a second. The lights have turned yellow. And of course the red light beeps, the red light flashes every time in coincidence with the beeping because it's connected and it will release at exactly the same time. If you want to go back into regular mode, you hit the mode button, the lights turn from yellow back to green, and we're back into regular mode. And this takes about 5 to 6 or 7 seconds to charge up. As you can see, it's much slower. Each one has its advantage, and I'll talk about those a little bit later. To turn the unit off, you simply hold the on-off button down for 2 seconds, which I'll do now. The unit turns itself off, and you're ready to move on to the next step. I'd like to talk about the magnetic field produced by the magnetic pulsar. Our magnetic pulsar produces a rather unique magnetic field. We call it a DC spiked or time variant magnetic field. It's not like an AC field, which is alternating, which gives you a frequency. Ours is like a spike, which is generated, for instance, if you're in regular mode, every 5 to 7 seconds you'll get a spike, and that spike is the output of the magnetic field. In fast mode, that spike happens maybe every second. It's the same type of magnetic field, it just simply happens faster and a little bit less intensity. I'll talk about the differences in the modes in a moment. But what's important to remember that the output of the magnetic pulsar is a spike. That spike is 6,000 Gauss in intensity measured at the face of the coil. and it lasts 2.5 milliseconds, or 2.5 thousandths of a second. Now this is the coil. This is where the action happens. There's a coil of wire in here, and the magnetic field is generated within this coil. Every magnetic field has a polarity. What's unique about our DC magnetic field is that the polarity remains on the same side of the paddle and doesn't change. On the SOTA logo side is actually the south pole. On the other side, we've labeled it intentionally north or bio-north, the minus pole. Because our field is a DC magnetic field, that will remain as north. That north or bio-north is the same as the Earth's north pole. A compass, if you were to take a compass, every time it releases a pulse, it'll point towards the north of our hand paddle, the same way in which a compass points towards the north pole of planet Earth. Now don't take a compass close to our magnetic pulsar, because you could demagnetize the compass. We'll talk about how to know when the magnetic pulsar is giving a field a little bit later on. As I mentioned, it's 6,000 Gauss in regular mode, and that's at the face of the coil. Magnetic fields drop off at either quarter decay or even as I mentioned, the inverse square law or inverse cube law. And that just means that the magnetic field drops off faster as you get out further away from the face of the coil here. So if you double the distance, the actual output may be a quarter or less. So you need to have high magnetic Gauss in order to have a deep penetrating field. We measure about 100 Gauss out to about 9 inches, and it's shaped somewhat conical on both ends, equal on both sides. Equal on both sides. So you'll have it this side and as well as on the other side. In the fast mode, it's about 2,500 Gauss at the face, so we have a little bit lower output, and we can measure 100 Gauss out to about 7 inches. The magnetic field itself, you can't feel it, you can't taste it, you can't see it, so it's actually invisible. And I'll show you ways in which you can test to make sure your magnetic pulsar is actually giving off a field. As I mentioned before, our magnetic pulsar is a 2-speed pulsar. It's regular mode and fast mode. In regular mode, it's the highest output, 6,000 Gauss at the face of the coil. It takes approximately 5 to 7 seconds to build that charge up, and the unit will count 255 pulses, making one session. And that session will then last 255 times 5 to 7 seconds, about 20 to 30 minutes. In fast mode, it takes approximately 1 second to build a charge, and we count 1,400 pulses, 1,400 seconds, and it translates to about 20 minutes. So the session then will be the same for both, but in regular mode, you have higher output, but less pulses for that 20 minutes to 30 minutes. In high-speed mode, you have a little bit lower output, but you have far more pulses per that 20-minute session. And that's something that you can use depending on what you want to do with the unit. Now the magnetic field, some people, extremely sensitive people, may be able to feel the magnetic field. I certainly can't. Magnetic field comes off in like a conical shape. It's exactly the same on both sides. It's identical north and south on both sides. And as I mentioned before, in regular mode, 6,000 Gauss, we can measure it out to about 9 inches. So how do you know that the magnetic field is being delivered? When I turn the unit on and I go into regular mode, I have the little indicator beep that comes on that tells me the pulse is being released. You might actually feel a little movement in the coil. What happens is that the magnetic field is being generated. There's a coil of wire in here, and it's contracting very rapidly. There's lots of power being created here, and that contraction makes the paddle move slightly. On some paddles, and we try to keep this as quiet as possible because we have plastic, we have metal coil inside, there may be a bit of movement between the coil and the plastic. You may actually hear a little ticking sound in the paddle. You may not. It's okay one way or another. Some people like it, some people not, but we actually fill it with silicone. We're trying to keep it as quiet as possible. You may have one that you can hear, you may have one that you don't hear. It's perfectly normal. But when the magnetic field is released, because you can't feel it, for most people can't feel it, how do we know that it's actually happening? We'll have a little demonstration set up here for you. I'm going to be turning the unit on in regular mode, which gives me the highest Gauss output. I'm going to turn on the audible indicator so you can hear every time the pulse is released. And what I have here, I've made a coil of wire with a little LED light in the end. There are no power connections, there's no battery involved, it's just simply a coil with a light. What I'd like to demonstrate is the magnetic field coming off. The magnetic field will interact with this coil and generate electricity. It actually generates microcurrents of electricity. That's one of the features of a moving magnetic coil. Our magnetic coil moves that spike and will generate electricity. Let's see if it can generate electricity right through my neck. So I'm going to turn the unit on. I'm going to go into audible mode so you can hear every time, 5 to 7 seconds, it'll release a pulse. I'm going to put the north side, and it wouldn't matter if I use north or south, they're both equal. And I'm going to take my coil, and hopefully you will see the light come on every pulse. There it is there. There it is again. If I bring it very close to the coil, the light will be brighter because it's more intense of a magnetic field. As I bring the coil away from the paddle, the light will be slightly diminished. And there you go. And that indicates that the strength of the magnetic field has tapered off. Now, if you don't have a coil of wire around, you can demonstrate the magnetic field with a standard pair of pliers. You need to use a pair of pliers that's actually made out of steel, so it's attracted to magnets, or else this demonstration will not work. So just take an ordinary pair of pliers and bring it up maybe a ½ an inch away. Every time it releases the pulse, it's going to, there it is again. It's a very strong field. So what's happening here is the magnetic field is attracting the metal in the pliers, and there we are. We get the sensation of it. It's very, very strong. If I go into high speed mode, it's just simply faster, but it's a little bit less strength. And that's what the whole difference is between the modes. One's stronger, fewer pulses, one's faster, a little bit less strength. Now, the magnetic field that comes off here will also interact with any other metal. So you could try this demonstration against a large piece of metal, maybe from the side of an oven or maybe fridge or something like that. So just make sure that it's a magnet type of steel and not aluminum. Aluminum will not interact like this. Now, several years ago, I demonstrated putting a 1/4 inch washer on the paddle, and I flew that washer across the room. And people may say, well, they try it here and it doesn't work, or it just slides off. I just want to mention that in that time, I actually had an open coil where you could see the coil of wire, and I was able to put the washer inside the coil. Because we seal this coil up, a lot of energy, a lot of electricity is being generated here. For safety reasons, we encase this all in plastic. So you don't get the same effect of that washer shooting out because I can't put it inside the coil where I previously demonstrated. But the magnetic field is still the same. It's just the placement of the washer is slightly different. So that's why I use these other demonstrations here, so you can see very clearly that it truly is happening. During the operation of the magnetic pulser, I'm just going to turn it off here, hold it down for 2 seconds, turns off. Now when the unit is operating, a tremendous amount of energy is being delivered to this coil. This is going to get hot. And you just want to make sure that if it gets too hot that you don't hurt yourself, you don't burn yourself. And what's nice about magnetic fields is they basically go through anything. They'll go through cloth and material and that type of thing like it's not even there. So if it gets too hot, simply use it through a shirt, something like that, or put a dish towel over it, or some people even put a sock over it just to keep the hot surface away from you. But the fact that it gets hot is important. It tells you it's actually working. So that's very important. If it's not getting hot, there's a problem with your unit. Of course, after maybe 2 or 3 sessions, it just may simply need to cool down. So just turn the unit off and let it cool down. When the unit is operating, One thing I need to say, after the session is done, the unit will go into sleep mode, which means that it'll sit there and wait for about 30 seconds for you to restart. If you don't restart, it just turns everything off. So just keep that in mind after the unit shuts down, that it's just sitting there waiting for you to do some action. If not, just turn the unit off or just leave it. Now the magnetic field will go through most materials, but when it hits metal, it could be dispersed. So some of the things which you need to be aware of is that you don't want to be putting the magnetic field against an area where you may have an implant, a metal implant. Even though the implants may not be magnetic, like they could be titanium, there may be some interaction. You may get heat built up in that area. You may even get a bit of electrical generation, microcurrents, and it may be uncomfortable. So we generally say if you have implants, don't use them in that area. Definitely don't want to use it if you have any kind of pacemaker or any other kind of electrical implant. We don't want to have any interaction between the magnetic field and your sensitive pacemaker or other sensitive electrical equipment. So please don't do that. Another thing to make sure to keep the magnetic field away from are things like your credit cards. It will annihilate a credit card in one zap. And also your computer hard disk. We did a test. We wanted to see if it truly would. And we took a hard disk against the paddle, and 2 pulses, that hard disk was dead. So keep it away from your computer. When I say keep it away, a foot, 2 feet away, nothing's going to happen. The magnetic field at that point is so tiny, it's not going to interact. So just don't put your credit cards close. Keep them, let's say, a foot or 2 away. Homeopathic remedies, keep those away from the magnetic field. There could be an interaction. So again, just keep that from your wallet too. Make sure the magnetic field, you're not pulsing on your pocket and you have your wallet in there. So that will destroy all the magnetic strips and all your credit cards and your license and that type of thing. Other than that, the magnetic pulsar will operate very nicely for the sessions for you, and I think you're going to find it's going to be very useful in your endeavors. And thank you very much, and happy pulsing.